Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week in Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science and society. Leading off, we're going to talk about hurricanes, monster hurricanes. We've been hit week after week after week with these huge 100-year hurricanes. And what's behind it? Well, it turns out that PBS television has a new documentary exploring a new science, paleoclimatology. It used to be thought that if you want to understand the weather, you just go outside and lick your finger. Well, now we have satellites, but satellites only give us real-time information about the weather. What about the weather of the past? What about the weather going back centuries, thousands of years? In order to understand hurricanes, you have to understand whether or not we are entering a new hurricane cycle, or perhaps something is destabilizing the atmosphere of the planet Earth. So we'll talk about that. Also, speaking about hurricanes, we'll say a few things about computer modeling. It turns out that at Penn State, they just recently released a computer model of New York City through the year 2300. Think about that. We're able to look at the weather into the past and the weather into several centuries, and we're talking about whether or not sea level rise or storm surges would be the greatest threat to New York City. And speaking about New York, let's talk a little bit about pollution. New York City and London used to be the center for industrial pollution on the planet. However, things have changed. However, we still have pollution. There's a new study coming out from the Simon Fraser University showing that 16% of the deaths in the world can be attributed to pollution. That is astounding. Think about that. Out of every 100 people who die on the planet Earth, 16 of them die unnecessarily because of pollution. So we'll study a little bit about how that study was done and what the implications are. And then we're going to go into outer space. First of all, did you know that a rock from outside the solar system is whizzing around the sun even as we speak? Yes, that's right. It's about 1/5 of a mile across. It's an asteroid, apparently from another solar system. It's not from our solar system at all. And the question is, how do we know? And what does it mean? Next, comets are also in the news. It turns out that our satellites are so sensitive now that we can actually detect comets going around other stars in the universe. Personally, I never thought that would be possible in my own lifetime. But yes, our instruments are sensitive enough to even pick up comets in other solar systems in outer space. And then we'll say a few things about the latest developments in astronomy in exploration. Well, let's just jump right into some of the big stories of the past week. Well, you've heard it all before. We had Hurricane Harvey, Hurricane Irma, hurricanes that devastate the Florida Keys, hurricanes that devastate Puerto Rico. I mean, it just keeps going on and on and on. And now PBS television is coming out with a new documentary talking about paleoclimatology. That is, what was the climate hundreds, thousands of years into the past? First of all, you may ask yourself a simple question. How do we know anything about the temperature of the past? Well, of course, we have human records, but human records are very spotty and inaccurate. And so, for a first-order approximation, we look at tree rings. Tree rings expand every year because of the rainy season. And by cutting open a tree, you can actually go back centuries, in fact, thousands of years into the past. And not just tree rings, but we can also use lake sediments. If you were to drill right into the bottom of a lake, you're going to pick up sediments, for example, from floods and volcano eruptions that took place hundreds of years ago. And then if you go to the North Pole and the South Pole and dig into the ice, you can pick up ice cores that go back 500,000 years into the past. It turns out that not only can you see evidence of catastrophic activity like sediments laid down from volcano eruptions, you can also calculate the temperature that existed thousands of years ago. You see, there are air bubbles that are trapped inside the ice cores, and by analyzing the chemical composition of the air trapped in the ice thousands of years ago, you can actually get an equation to calculate the temperature that existed back then. And then by looking at the air pockets inside the ice cores, we can determine how much carbon dioxide there was in the atmosphere. Certain things just jump right out. First of all, it turns out that carbon dioxide levels and temperature levels go up and down like two roller coasters in synchronization. When the CO2 level goes up, the temperature goes up. Now, why should we care? Because by going to different kinds of areas in the Caribbean, we can actually calculate the temperature of the water back then. And the temperature of warm water determines the frequency and strength of hurricanes. Because that's where the energy of a hurricane comes from. It comes from warm water. First of all, warm water heats the air on top of it. Hot air rises. And so as hot air rises, it begins to spin because the earth spins beneath it. That's called the Coriolis force. And bingo, you get a hurricane. Now, by looking at the human data, you can get some inkling as to what happened centuries ago. For example, in 1780 in the Caribbean, there was a gigantic monster hurricane, the largest in recorded history, that hit Haiti and Cuba back in 1780, killed 22,000 people. It was an enormous hurricane. 22,000 people were killed. 5,000 more people died of starvation and disease. And then the question is, are there more monster hurricanes like the one of 1780 and the ones, of course, of 2017? Well, this is where paleoclimatology, where we go to the cutting edge. Now, as I said, for ice cores and lake sediments and tree rings, we can use that to determine the temperature and general weather conditions centuries, thousands of years ago. But hurricanes are much different. Hurricanes, of course, only last for a few weeks, few days, and they're very transient, and they don't leave much evidence. So what scientists did in this PBS documentary was they looked for seafloor sediments. Not lake sediments, but seafloor sediments, and also stalactites in caves. Caves have some water that drips down from the top of the cave. They carry sediments, and over thousands of years, they create a stalagmite and a stalactite. By cutting them open, by looking at the chemical composition of the stalactites and stalagmites, then we're able to reconstruct an approximate history of the hurricanes that hit the Caribbean. So what does it all mean? First of all, is there a smoking gun by which we can say, aha, that's why the year 2017 went down as this horrendous year of the hurricane? You can't even say with certainty that global warming directly caused these monster hurricanes. You see, global warming is an average phenomenon. If you were to graph these on a chart, then you could start to see straight lines and regularities. But yeah, every individual hurricane is very difficult to say that it was due directly to global warming. However, the documentary is pretty clear. When you look at the seafloor sediments in the Caribbean, you look at stalactites in caves, what you find is the frequency and ferocity of hurricanes is directly related to the temperature of the water. And the temperature of the Caribbean is getting warmer and warmer. As a consequence, that's the engine which helped to energize these monster hurricanes of 2017. So was it directly caused by global warming? Well, maybe, maybe not. But in terms of an average phenomenon, it fits right on the chart. Now, what does that mean if you want to buy a beach house in Florida? First of all, the tremendous Florida real estate boom took place in the 70s and 80s, while back in the 50s and 60s, there were monster hurricanes that hit Florida. As a consequence, there was not much building activity in the early years, but in the later decades, there was a tremendous boom in housing because people were lulled to sleep into thinking that the hurricane seasons were basically over. Well, we now know that's wrong. So you may think twice if you're thinking about buying beachfront property in Florida. And speaking about Florida, what about New York City, where I live? Well, it turns out that at Penn State University, they created a computer program that wanted to calculate damage caused by storm surges and rising sea levels. First of all, they found that the greatest indicator of damage was the level of seawater, not so much storm surges. However, as sea levels begin to rise, storm surges become more ferocious. In fact, by the year 2100, a monster storm surge would be 17 feet tall. Think about that. Think of a wave that's 17 feet tall coming your way in the year 2100. In the year 2300, it'll be 50 feet tall. Well, you can kiss many skyscrapers goodbye. You can kiss much of Manhattan goodbye if the storm surge and a maximum scenario would be 50 feet above sea level. And so these are computer programs done by Penn State. And you can also use these computer programs on other cities. And so if you want to know whether your city is going to be underwater in the near future, you may want to consult the climatologists at Penn State who have computer programs calculating the level of seawater and from that, the amount of damage that you're going to get with storm surges. And speaking also about thermal pollution, let's talk about chemical pollution as well. It turns out that at Simon Fraser University, they did a rather straightforward study. First of all, they took the total number of deaths that took place around the world and then calculated what percent of those deaths come from pollution. Well, the numbers are very interesting. They analyzed 9 million premature deaths, of which 16% can be attributed to pollution. I mean, think about that. 16% of every death on the planet Earth can be tied to pollution. That's 3 times more than the deaths from AIDS, tuberculosis, and malaria combined, as 15 times more than the deaths from all the wars and crimes and violence on the planet Earth. It's one of the largest single sources of death on the planet Earth. And where did these deaths occur? Well, 92% of these deaths came in lower income levels. Now, you can sort of say that history repeats itself. If you go back 100, 200 years and you look at the Industrial Revolution, you see times when London was completely fogged over because of the enormous pollution from coal burning and things like that. And you can actually see the rise in respiratory deaths as a consequence of that. Well, that was London hundreds of years ago. And now, in some sense, we're repeating that around the world. And as nations industrialize, they too are creating large amounts of pollution. And the price you pay for that pollution is you're going to kill a lot of your people. That's what the numbers show in a study done at Simon Fraser University. And also news from outer space. I mean, way out in outer space. We're talking about going outside the solar system. For the first time in history, scientists have gotten conclusive evidence of an intruder from another solar system, another system of planets far beyond our sun. It was seen by telescopes in Hawaii. The object, at first, people thought maybe it was a comet from another solar system. Now we know it's not because it doesn't have a tail. It's perhaps just an ordinary asteroid of some sort. It is about 1/5 of a mile across. and it is just now whipping around our sun and then returning back into deep space. Now, you may ask yourself a simple question. How do we know? We don't have any space shuttles out there to photograph this thing. How do we know that it came from another solar system? Well, the way we do it is actually rather simple. We have Newton's laws of motion. Therefore, we can track these things using our telescopes by taking photographs of the night sky at different times, and then by calculating the trajectory of this object, we can apply Newton's laws of motion. By applying Newton's laws of motion, we can run the videotape backwards or run the videotape forwards. And when we run the videotape backwards, we find that the trajectory of this asteroid is unlike any asteroid or comet that we have ever observed. Instead of going around the sun in the solar system's plane, called the ecliptic plane, this object is going around the sun off the ecliptic plane, and if you complete the dots, you see that this object came from another solar system. And so we now know that, yes, objects will go between solar systems. Now, why should you care? Well, one theory that has gained some traction recently is the fact that the first DNA may not necessarily have come from the Earth. It turns out that 3 or 4 billion years ago, we had tremendous amounts of meteor and asteroid bombardment, which would make life very difficult to form on the planet Earth. But as soon as this bombardment ended, boom, DNA gets off the ground over 3.5 billion years ago. So some people say that it's just too short, a few 100 million years, and DNA gets off the ground. Some people say, therefore, that maybe DNA didn't come from the Earth. Maybe DNA came from outer space, maybe from Mars. Maybe an asteroid plowed into Mars, or for that matter, maybe DNA came originally from another planet in outer space, going around another sun. Of course, we don't have a space shuttle now. We can't intercept this position is. However, it's intriguing to realize debris from other solar systems that interact with the asteroids that are out there. It turns out that by analyzing the conclusively shown evidence of a comet circulating another star in the universe. This is amazing. An extrasolar comet. Now, why is that amazing? Because planets are very difficult to see by telescopes because they don't emit light, especially planets going around other stars. Therefore, how do we do it? We look for the planet moving in front of the mother star. Starlight dims a little bit. If it's a Jupiter-sized planet, starlight will dim by about 1%. So by looking for the dips in starlight, you can then reconstruct what is moving around stars in the galaxy. That's how we know that 4,000 planets have been identified that are revolving around other stars in the galaxy. Now, it turns out that we can even detect Earth-like planets going around other stars. It's very difficult because Earth is very small. Now, the new breakthrough is we can detect comets going around other stars. Comets are real tiny. Halley's Comet, for example, the famous Halley's Comet that whips around the solar system, it is only about 10, 15 miles across. Its tail, of course, is huge, but the comet itself is only 10, 15 miles across. Therefore, the fact that our satellites can detect a comet that's only 10, 15 miles across, orbiting another star in the Milky Way galaxy, that is astounding. First of all, the comet itself is very small, 10, 15 miles across, but the tail, of course, is much bigger. The tail will actually unfurl over a distance of several million miles to up to perhaps even 100 million miles. And so the tail of the comet, we think, is what's being observed by ground-based telescopes and by the Kepler satellite by looking at the dimming of starlight, not by 1%, but by a fraction of 1%. When Jupiter goes in front of another star, starlight dims by 1%. A comet tail, would dip starlight perhaps less than 1%. Now, let me say something about the mail I get. I get a lot of emails. A lot of emails concern things like, well, ancient aliens and Planet X. Some people believe that there is a new planet out there called Planet X that could whip around the Earth, causing enormous destruction, maybe even hit the Earth. Well, let me tell you right now, we see no evidence of Planet X. We've scanned all the debris, even beyond Pluto, and we see nothing but small icy bodies outside the orbit of Pluto that are about the same size or much, much smaller than Pluto. We see no evidence of Planet X. Now, some people may be confused by the story hitting the newspapers that there is another planet, a giant planet the size of Neptune, that is orbiting the sun way out in outer space. Yes, that is true. However, it is so many billions of miles away from the planet Earth that there's no way that this new planet is going to collide with the planet Earth. So to sum up, at the present time, we see no evidence of Nibiru, the Planet X. We see no evidence of that. We've scanned all this stuff going outside the orbit of Pluto. We see no evidence of that. However, there is a Neptune-sized planet way out there in what is called the Kuiper Belt of comets, and it is apparently real. Its gravity is so strong that it makes nearby objects jiggle a little bit, and by looking at the jiggling and putting it into a computer program, you can actually calculate that, yes, something is tugging on these outer planets. And speaking about aliens from outer space, there's one question that I always get, and that is the question about ancient aliens. They've seen stories on the History Channel, for example, talking about, well, strange hieroglyphics, strange pictures that seem to indicate perhaps astronauts. Astronauts from a distant world once upon a time landed on the planet Earth, freaked out the Earthlings on the planet, and as a consequence, the memories of these encounters were engraved in stone. Well, maybe, maybe not. I mean, it's not the smoking gun. When you look at all these ceremonial headdresses and contraptions, maybe they were spaceships, or maybe they were just headdresses and different kinds of religious contraptions used in ceremonies. However, there's one form of ancient aliens that is very hard to dismiss. And that is, if you look at the movie 2001, it talks about the fact that maybe ancient aliens landed on the moon. Robotic aliens that left a probe on the moon that would be stable for millions of years because there's no erosion on the moon. And the probe would simply wait and basically analyze the progress of Homo sapiens on the planet Earth. Now, if you think about that, that is perhaps mathematically the most efficient way for an advanced civilization to scan the galaxy. There are so many planets in our own galaxy, so many galaxies out there. How can an intelligent spacefaring creature possibly catalog all of these things? Well, the way to do it is to send self-replicating von Neumann probes to the various moons. These are robots which can make copies of themselves, just like in the movie 2001. Starting with one robot on the moon, you have maybe 1,000 that it creates by creating a factory on the moon. Each of these robots blast off to the next solar system, where they land on the moon and create 1,000 more. So starting with one robot, you get 1,000, then 1,000,000, then 1,000,000,000, 1,000,000,000,000, and quadrillion, and pretty soon you have a gigantic sphere, a huge sphere of billions and billions of von Neumann self-replicating probes that are beginning to colonize the nearby moons. Now, you've seen this before in biology class. Think of the way a virus propagates. A virus is just a molecule, and yet after 2 weeks, it creates trillions of copies of itself, so you get a cold and you start to sneeze. And so perhaps this is one way in which aliens could actually begin the process of colonizing the galaxy. with self-replicating von Neumann probes. Now, how big are they? What do they look like? No one knows. But you figure they must have nanotechnology. That is, the ability to create machines at the atomic level. In other words, these von Neumann probes may be the size of a bread box. Perhaps you have one in your backyard, and you don't even know that you have been visited by aliens from outer space. So you see, we've been brainwashed by Hollywood and the newspapers to believing that these flying saucer people would come down in gigantic flying saucers. Why? Perhaps they would come down as small little probes, and their object is not to make contact with us, but to simply land on the planet Earth, multiply, and basically monitor the planet Earth. Because, of course, there are so many planets in the galaxy. We've already located 4,000 planets in our own galaxy. The total galaxy count perhaps is on the order of 20 billion Earth-like planets in our own Milky Way galaxy. And so perhaps the mathematically most efficient way to explore the universe is not through ancient aliens landing on the planet Earth, making contact with primitive Earthlings. That's rather inefficient. The mathematically efficient way is to send robots that self-replicate and then could begin the process of colonizing thousands of planets in the Milky Way galaxy. So, who knows? Maybe you don't have to be abducted by aliens in a flying saucer to encounter extraterrestrial intelligence. Perhaps in your backyard, there's a tiny von Neumann probe using nanotechnology, which is in your backyard collecting data on the planet Earth. It can't be ruled out because, of course, we've been brainwashed into thinking that starships are gigantic objects. Maybe, just maybe, using nanotechnology and self-replication technology, the aliens have been able to compress it into a tiny von Neumann probe, perhaps no bigger than a bread box. So the next time you go outside in your backyard, just realize that, hey, perhaps we have been visited by aliens from outer space. Who knows for sure? Well, I'm afraid that's it for the first part of Exploration. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City University of New York. And in the second half of Exploration, we're going to be bringing on our good friend, Dr. Seth Shostak of the SETI Institute. We're going to talk about the science of aliens from outer space. What would it take for us to make contact with them? What will they be like? How will we interact with civilizations that may be thousands, millions of years ahead of us? We're going to talk about all these things with Dr. Shostak. Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. In the first half of Exploration, we mentioned the fact that science is so advanced now that we can actually detect asteroids from other solar systems and also comets revolving around other stars in the galaxy. Who would have thought that science would be able to detect objects that are 10, 20 miles across, that are light years away? Well, then the question is, with our instruments being so sensitive, why don't we pick up any emissions from intelligent life forms? After all, the Kepler satellite and other telescopes have detected 4,000 planets going around other stars. And we even have a census of the Milky Way galaxy. It turns out that about 20% of all the stars you see in the galaxy have Earth-sized planets going around them. Think about that. About 20 billion Earth-sized planets in our own backyard. Well, with us today is Dr. Seth Shostak, who will try to answer some of the questions. If there are so many life forms out there, maybe some of them are intelligent, and why don't they land on the White House lawn and announce their existence? Well, many people have different theories about this, but one person who wants to do something about it is Dr. Seth Shostak. He has a PhD in physics, like myself, but instead of being a professor at some distinguished college, he's devoted his life to search for alien signals from intelligent civilizations. That's right. He sacrificed a promising career in physics in order to chase after alien signals in outer space. Now, first of all, everyone, it seems, has some kind of anecdote about a UFO or some kind of mysterious lights in the sky. For example, I was speaking in Chicago the other day, and I was in a taxi, and the taxi cab driver swore that he saw a UFO. Not just a blink of light far in the distance, but a huge, gigantic flying saucer that hovered overhead and then disappeared. Now, he had, of course, nothing to gain by talking to a passenger in the back of his taxi, talking about an encounter with a flying saucer. You might think that he might scare away some of his customers. So why would he do something like this? Maybe, just maybe, there was a flying saucer that he encountered. Even President Jimmy Carter said that he saw a flying saucer, and he told the military about it and asked the military to investigate. Well, according to one story, what Jimmy Carter actually saw was the planet Venus. Because you see, we get confused by objects that don't move when we move. When we move our head, we know that the mountains don't move so much, but objects very close by move a lot. However, if there's something right next to you and you move your head, then the body gets confused, thinking that this object sitting over your shoulder is actually very far away because it doesn't seem to move. That's why many people think that Venus is following them, that the moon is following them as they move around. In fact, children often say that to their parents. How come the moon is following me? Now, that, of course, does not explain everything, but it does explain why perhaps the President of the United States once upon a time thought that he was being chased by aliens from outer space. So what we're going to ask Dr. Seth Shostak, first of all, is how confident is he that radio is the way to detect the presence of aliens from outer space? Our special guest, Dr. Seth Shostak, director of the Search for Extraterrestrial Intelligence, who has devoted his life to eavesdropping on radio emissions from aliens in outer space. Maybe one day we'll pick up the equivalent of I Love Lucy being broadcast from an alien civilization thousands of light years in the heavens. Who knows? And then the next big question is, what do you do? What do you do if you've actually made contact with an alien civilization? We'll talk to Dr. Shostak about that.
Well, that's actually a good point because, of course, the aliens haven't sent us a fax telling us where on the dial they might be broadcasting. So you have to sort of second guess what frequencies, what part of the dial makes sense. And that idea had already been explored, even though Frank Drake didn't know that, by a couple of guys who at that point were at Cornell University, a couple of physicists by the name of Giuseppe Cocconi, and Philip Morrison. Anyhow, these two guys had already thought about what frequencies make sense if you're going to send messages between the stars. And they said, well, look, there's kind of a natural answer to that because there's one frequency everybody will know, and it turns out to be 1420 megahertz on the dial. You might think, well, what's special about that? It turns out that hydrogen, which is by far the overwhelmingly most common element in the universe, hydrogen naturally emits some radio emission at 1420 megahertz. So all astronomers, of any sophistication in the universe will know about this frequency. So they said, look, that's a natural frequency. Everybody will have it marked on their radio dial. Let's try listening there. Frank Drake came to the same conclusion rather independently. And so the first experiments were done usually with a receiver that only had one channel. It could only listen to one channel at a time, just like your auto radio, and set that frequency somewhere near this 1420 megahertz magic frequency of the dial. Now, as time went on, this kind of experiment became much more sophisticated. Today, the receivers that are used for SETI listen simultaneously to tens of millions of channels at once because, you don't know exactly which frequency might be the one they're using, but they tend to look at that part of the dial around 1420 megahertz. Not always. Sometimes they'll do experiments where they're looking elsewhere, but usually you're covering maybe 1,000 or 2,000 megahertz around that frequency. So, it's a small fraction of the dial, but it seems to be a pretty good one. No one's ever come up with a better argument about where to tune.
Okay, now let's talk about Drake's equation, which is taught in every elementary astronomy course as scientists try to get a reasonable scientific estimate of the probability of intelligent races throughout the galaxy. So tell us a little bit about Drake's equation.
Well, the equation actually has an interesting history, or at least semi-interesting. Frank Drake had done that first listening experiment in the spring of 1960. So, gosh, that's 45 years ago. It was in April, I think, 1960. Anyhow, so that generated a lot of interest. I mean, he didn't find the aliens, but it generated a heck of a lot of interest. And so the next year, he had a meeting, also in West Virginia, at the observatory, in which he invited all the kind of professional scientists who were interested in this work. That total was like 10 or 12 or something. It was a fairly small number. And as an agenda, he was sitting around thinking, well, this meeting's coming up in a couple of weeks. I need an agenda. So as an agenda for this meeting, he wrote down this very simple equation, which has subsequently become known as the Drake equation. And all it does is try to estimate something called N, where N is the number of civilizations in our galaxy. Just let's confine ourselves to our galaxy that are broadcasting right now. The number of star systems, if you will, that are producing signals now that we could detect. Now, clearly, that depends on, well, how many stars are there in the galaxy, and what fraction of those have planets, and what fraction of those planets have produced life, and what fraction of those that have produced life have produced intelligent life, and what fraction of those have produced technology, and what fraction of those are actually on the air right now. Okay, so it's a whole string of terms. There are actually 7 terms in the equation. You can find it in almost any textbook on astronomy, and that's the Drake equation. And it would be great because it would tell you, what are your chances of success? I mean, if N is only a few, then the chances that you'll find these guys is pretty small. But if N are thousands or millions or some very large number, Carl Sagan thought that the value of N was several million. Well, if that's true, then, you have a pretty good chance of tripping across a signal sooner or later. So, unfortunately, of course, we don't know what N is. There are a bunch of terms in the equation that we simply don't know. So it's more of a talking point kind of thing than it is an equation that you can actually solve or use.
Other scientists say bah humbug. We had Professor Brownlee on our airwaves about a year and a half ago, and he said that Drake's equation is flawed. Flawed because there are new astronomical bits of information that show that, to get life is more difficult than we thought. He mentions, for example, that you need a large moon. Without a large moon, the Earth would eventually tumble in its orbit and over hundreds of millions of years, and that would make DNA impossible. He also mentioned the fact that at one point the entire Earth was frozen over. We were Snowball Earth. And again, DNA would be very hard to get off the ground under those circumstances. He mentions you have to have a large Jupiter in order to clean out the debris of the solar system. He also mentions you have to be a certain distance from the center of the black hole at the center of the galaxy. Otherwise, you get fried by being too close to this very radioactive core at the center of the galaxy. But if you're too far out, then there are not enough heavy elements to create DNA and higher molecules. So, what are your thoughts? Is the Earth in some sense unique, as Professor Brownlee was hinting at? Or do you think N is quite large, as Carl Sagan believed?
Well, of course, nobody knows, so everything I'm going to tell you is my opinion on it,
okay.
Obviously.
Good enough.
If we knew the answer, we wouldn't be discussing it, but it's true. Don Brownlee and his colleague Peter Ward at the University of Washington up in Seattle wrote this book about 5 years ago called Rare Earth, in which they had indeed, as you indicated, kind of a laundry list of, reasons why Earth might not be just a run-of-the-mill planet. Earth might be very, very special, so special that, in fact, although there might be some other life out there, it's not going to be very sophisticated life. It isn't going to be intelligent life. And so our SETI experiments are kind of a waste of time. That was their thesis. And since this was reviewed, by the way, in the New York Times, this book got a lot of play. And but if you actually look at this laundry list, you find that the items on it are not terribly convincing. But let's take a couple of the ones you named, for example. The fact that the Earth has a large moon, which kind of stabilizes the spin of the Earth. Okay. Now, if we didn't have that large moon, and by the way, a large moon is kind of a rare thing. You know, Mercury doesn't have a large moon, has no moons. Venus doesn't have a large moon, has no moons. Mars has a couple of moons you could walk around in an afternoon. Tiny moons, they don't help. Earth, on the other hand, among the rocky planets, is the only one to have a large moon. Okay, and sure, it does stabilize the Earth's spin. But if you took that moon away, yes, well, the Earth wouldn't, just go completely nuts. Every now and again, the North Pole would come down to, Connecticut or some other place, that sort of thing. But it would take hundreds of thousands, maybe millions of years to do that, right? So it's such a slow event that even for complicated life like freshwater otters or whatever, right, they can just walk away from that problem. If you've got 100,000 years, before the North Pole gets to you, you have plenty of time to move. I mean, that isn't fatal to life. That's not fatal. It might be an inconvenience, if you had a society with a lot of cities, you might not want it to happen. But it's so slow. It's not fatal. Now, here's another thing in your list there. You mentioned we're fortunate to have Jupiter because Jupiter has cleaned out the inner solar system of all these big rocks that otherwise might, slam into your planet and ruin the whole day, just the way it happened 65 million years ago, taking out the dinosaurs and 75% of all other species. Well, sure. But on the other hand, big Jupiters are not rare. We know that. In fact, all the planets we've found around other stars are like Jupiter are bigger. So big planets are not rare. But even aside from that, you could argue that maybe life on Earth would have gotten a little bit farther had we not had such a big planet as Jupiter out there. Because, in fact, if the dinos had been wiped out 50 million years earlier, we would be 50 million years ahead of where we are today. We'd have the cure for death, whatever. It would be, maybe we'd be better off. So I don't find that a very convincing argument. I mean, you can look at each one of these arguments. The Snowball Earth, yes, there's some evidence, although it's somewhat controversial, but there's some evidence that there was a time, a few billion years ago, when the entire Earth was encrusted with ice. But there was life on Earth then. And that life wasn't wiped out by Snowball Earth. It just, had to sit there and, live at the bottom of the oceans for a while. But, a lot of life, well, all life was down in the oceans anyhow. So, it didn't wipe out Earth. It wasn't fatal. Okay, so all these things, yes, they might be an inconvenience, or they might not be, but in any case, none of them stopped life on Earth. None of them stopped life on Earth. So I really don't think...
Well, Professor Brownlee goes on, in fact, on and on and on, as I found out interviewing him. He also says that microbial life could, in fact, be quite common throughout the universe, but intelligent life... Well, take a look at the dinosaurs, he says. We've had life forms with spinal cords and nervous systems for hundreds of millions of years on the Earth, but humans... Only humans on the Earth, even on the Earth with such ideal conditions, it took hundreds of millions of years for humans to get off the ground. And even then, there were many times, a few thousand of us, 100,000 years ago to create the entire human race. The human race could have been wiped out many times during certain bottlenecks in our evolution. So he was basically saying that intelligent life is extremely rare, even if you have microbial life being common. What are your thoughts?
Well, he's right in that this is a controversial area. I think even more controversial than the question of whether you can get complex life on a lot of planets. I don't think that's so controversial myself. But just because I give you 1 million planets with life, right, and you let them cook for a few billion years, there is a legitimate question. What fraction of them will ever cook up something as clever as, as we are? and we are clever compared to most critters around, right?
That's debatable, but anyway.
Well, but in any case, I mean, we don't know because we still don't understand fully how, or even partially really, how intelligence evolved on Earth. What was it that produced intelligence on Earth? If it's rare in the sense of being accidental or contingent upon a lot of special circumstances, then maybe he's right. Maybe you got lots and lots of life out there. Maybe Captain Kirk takes the Starship Enterprise out into space and finds lots and lots of life in the galaxy, but it's all stupid. Okay, that's one possibility. But on the other hand, all the studies that have been done about how intelligence arose on Earth suggest that, well, what drove it was nothing that you wouldn't expect elsewhere. And sure, it took a long time before you got this far, but you needed some preconditions. You needed warm-blooded animals with a high metabolic rate. You needed all sorts of sort of biological developments. And then, in the last 50 million years, which of course is fairly short in the history of the planet, but in the last 50 million years, a lot of species have gotten smarter. Obviously Homo sapiens, but, and obviously our simian relatives, right? Chimps are pretty clever. But, birds are pretty clever. Even octopi are fairly clever. Whales and dolphins are fairly clever. There's been an increase in intelligence among, a couple of handfuls of species in the past 50 million years. It isn't just one species that got smarter. Now, we got smarter than they did, but if you were to visit Earth 2 million years ago, you would have found that the smartest things on the planet were not our simian ancestors, but some white-flanked dolphins. They had the highest IQs. And they didn't leave a lot of literature, but, they were the smartest things around. Mm-hmm. So it does seem that intelligence is actually kind of a fairly natural product of evolution once you get to a certain level of complexity. This is controversial, but at least the indications are that intelligence is not some sort of miracle.
Okay, well, shifting gears a little bit, we also had Professor Dan Wertheimer from the University of California at Berkeley on our airwaves a few years ago, talking about SETI at home. That is, on your home PC, you can get a chunk of this radio data and have your PC via its screensaver basically crunch some of the numbers to look for intelligent signals. What's been the progress for SETI at home in the last several years?
Well, SETI at Home was intended originally just to be a very short-lived project, maybe for a year or two, but it was so popular that it's continued. They expected, maybe 50,000 people, would download this free bit of software so that when they walk away from their computer, it's still humming away, that it would process a certain amount of SETI data that it would download from the servers at the University of California at Berkeley. Well, more than 5 million people have downloaded that software, mm-hmm. So that's, that's 100 times as many as they expected, and about a third of them use it at any given time. What they do is they distribute a little bit of the data they collect from the radio telescope down in Puerto Rico, the Arecibo radio telescope, which a lot of listeners may have seen in the movie Contact, movie GoldenEye. It's a great movie star. Yeah, they distribute about 1 or 2% of the data they collect there on the web for people using the screensaver. But the point is that there are so many people doing this with their home computers that it is by far the largest computer project, the largest computer, if you will, in the world right now. And those data are looked at extraordinarily carefully. So, it's really a very, very fine-tooth comb. They look at all the rest of their data right there at Berkeley using, the local Berkeley computers, but they can't look as carefully as they can at this small fraction of the data, which, are the prime data, if you will. Now, has anybody found something? Well, people find stuff all the time, of course. If you do these sorts of work, this sort of work, and you're using a big antenna like the one in Puerto Rico, you find signals all the time. That's right. You got this huge antenna. It's connected to a receiver that has millions of channels. Of course, you pick up signals. But of course, the question is that ET on the line, or is that AT&T on the line? Is it just interference from a telecommunications satellite or something like that? Now, what the guys at Berkeley do is they look at all the signals that have been found by people using their computers at home. And they look for those cases where a signal has been found more than once, in fact, more than twice. If a signal has been found 3 different times, right, not just by 3 different people, that doesn't count, but by, at 3 different times. In other words, the telescope was pointing at some spot on the sky and they find a signal, and then, 3 months later comes back to that same point. Somebody else finds it again at that same frequency, at that same spot on the sky. If that happens 3 or more times, then they say, hey, look, that's, kind of interesting from a statistical point of view. That suggests it's not just a noise spike. That looks like a real signal. And then they will go down to the telescope and will deliberately look at that spot on the sky for a long period of time, for a few minutes, whatever it takes, until they can verify whether the signal is still there. They have done that on several occasions. So far, no dice. But on the other hand, it is quite possible that somebody running SETI at home could, in fact, find the signal that would entitle them to pick up a prize in Stockholm and have dinner with the king.
And that, of course, would be perhaps one of the pivotal events in human evolution on the planet Earth.
I think so.
Well, let me ask you now the $64,000 question. What do you, as an individual, think N is, N being the number of intelligent planetary systems out there, and where are they?
Yes, well, of course, I don't know what N is either, but I tend to agree with Frank Drake, who still works here at the SETI Institute. His office is down the hall from mine. And Frank is now, I guess he'll be 75 in another month or so. But he's still as active as he ever was. And he's a pretty smart guy. one of the cleverest guys I've known. And if you ask Frank, look, this is your equation. What do you think that is? He'll say, well, I think it's probably around 10,000, which is kind of a conservative number compared to Carl Sagan, who thought it was a few million. I think Isaac Asimov thought it was 2/3 of a million. So Frank is saying about 10,000. Well, if it's anywhere between 1,000 and, well, some bigger number, if it's more than 1,000, then that means that the nearest aliens are within, on the order of 1,000 light years, okay, to us. Now, keep in mind that if you looked at the whole Milky Way galaxy, it's about 100,000 light years across. So this is, only like 1% of the way across the galaxy. 1,000 light years. That's far if you're trying to drive it in your Honda, but it isn't so far for a radio telescope. If that's the case, and it really is, it's up for grabs. Obviously, we don't know. But if that's the case, then our experiments should find a signal within the next 20 years, because within the next 20 years, we will have kind of searched stars out to that distance. So that's my bet. But on the other hand, we're not going to know the answer until we know the answer.
And what are your thoughts about, well, where are they? SETI so far has picked up nothing. Is that just a question of lack of sensitivity of the SETI antennas, lack of detectors, or is it because they're shy out there in outer space? Or maybe they don't exist? Or, well, what are your thoughts about why we haven't picked up any messages yet?
Yeah, well, this, I think that the answer is very simple. I think it's simply because we've not combed enough galactic real estate yet. But, there are people who say, no, the fact that you haven't heard anything yet means something. It means that they're not out there, because any society that was more advanced than ours, and most of them are going to be more advanced than ours. I mean, if intelligence really does occur on planets in a fashion that's not extraordinarily rare, then most of the societies out there will be much older than ours, because, after all, we're the new kids on the block. The Earth has only been here for 4.5 billion years. The galaxy has been around for like 3 times that length of time. So most of the stars out there are older than the sun. So if they're really advanced, then they should have been able by now to maybe colonize big chunks of the galaxy. Who knows? They should have been able to spread around. They should have, remote transmitters. They should be very easy to find, right? And the fact that we haven't found them sounds like some sort of paradox. In fact, this little argument is often called the Fermi Paradox, because Enrico Fermi, the physicist, the Italian-American physicist, was the first to point this out over a lunch at, I think it was Los Alamos in 1950. But in any case, that's his argument. I don't think I buy into that. I don't think it's a matter of them being shy, being coy. Maybe some of them are shy. Maybe most of them are shy. But if only one society has a powerful transmitter out there, then we have a chance of success. I think the reason we haven't found them yet is that we haven't looked very carefully. And all of that is going to change in the next few decades, mostly because of the march of technology.
Well, my personal point of view is that if there's an anthill in the country and you're walking down this country road and you bump into this anthill, do you go down to the ants and say, I bring you trinkets, I bring you beads, I bring you nuclear energy and DNA technology? Or perhaps maybe you step on a few of them.
Yeah, probably. I get phone calls just about every other day from people who have their own explanation of why we haven't heard anything, and it's usually because the aliens are put off by our environmental degradation and our, threatening one another with war and all that sort of stuff. But indeed, I think that from their point of view, none of that matters terribly much, any more than whatever wars the ants are getting into concern me. They don't.
Mm-hmm. Now, another stream of thought says that we're looking in the wrong place. For example, take a look at email. Email is compressed, email is broken up and goes through many cities and then recombined at the other end. So if an alien civilization had even a primitive email system, and we were eavesdropping on it, we wouldn't hear much at all. The signals would be compressed in a way that we don't understand. They'd be fragmented and redistributed and reassembled someplace else in a code we don't understand. So we could be listening in to messages that are teeming with intelligent things in it, but we are simply too primitive to understand it. What are your thoughts about that?
Well, I'm sure there's a lot of truth in that. I don't expect that we are going to understand any of these messages, even to the point of being able to sort of break them up into the bits that that make them up. And it's also true that, there are all sorts of methods for encoding information, for sending bits around that are fairly sophisticated that we use. For example, your cell phone tends to use what is called spread spectrum technology, where the signal is spread all over the dial. instead of being concentrated in one spot. That's very hard to find with a radio receiver unless you know all the details of their communications schemes. So, yeah, there are lots and lots of ways they could make the signal hard to find, but in the end it comes down to this. If they have a transmitter on, that puts a certain amount of energy somewhere in the radio dial, somewhere in the radio spectrum. And we don't worry about how it's encoded or what the message is or anything like that. We don't worry about the message when we do our SETI experiments. We're just trying to determine, is a transmitter on? We're looking for narrowband components to the signal. It's called a little, lots of excess energy, if you will, at certain spots on the radio dial. If we find that, we, of course, don't know what they're saying, whether it's something profound or whether it's something trivial like used car ads. We don't care about any of that. We're simply looking for evidence that their transmitters are on because, after all, that's the proof that we're after.
Well, I'm afraid that's it for Exploration. Once again, our special guest today was Dr. Seth Shostak, director of the SETI Institute, the search for extraterrestrial intelligence. Join us every week when we talk about science and its impact on society. Good day.